Welcome back. Let's do our next question. Block A, which is at rest on a horizontal rough surface, is used as an anchor to hold block B with a mass of 56 kgs in the air at a certain height above the ground. The two blocks are connected with a rope R, which makes an angle of 35 degrees with the vertical. Block B is suspended from the ceiling with cable C. Refer to the diagram below. And then we're given the information that block A experiences a frictional force of 200 newtons and the system is stationary. Calculate the vertical component of force in cable C. Right, so now we have the vertical component of force C and the vertical component of force R. So since the system is at equilibrium, it means that if we add the vertical component of C and the vertical component of R, we must get the weight. So we can say here the vertical component of C plus the vertical component of R should be equal to the weight. That's what we have to use here to get what? The vertical component of C. Right. Can we find the vertical component of R? Yes, we can. If you check here, we have, this is the vertical component. This is our 90-degree angle. 200 newtons is opposite the angle, 35 degrees. And then the vertical component of R is adjacent. So which trig ratio can you use here? The tangent of the angle 35, isn't it? So we can use that because we have adjacent and opposite sides. So 200, which is opposite, and then FRY, which is adjacent. Let me just write it like this and say tan 35 degrees is equal to 200 newtons over the vertical component of R. You see that? And then we can make the vertical component of R the subject here. Let's start by multiplying FRY tan 35 degrees is equal to 200 newtons. Then we divide by tan 35 both sides, then we get this. Okay, right. And then the vertical component of R is 200 over tan 35, and then which is this. Let's go back to our equation, this one. We have the weight, it's fine. Let's go back to the equation. So we substitute what we have. We have this, we have this. Okay, the weight is this, isn't it? Right, so we have these two. Then we can find our vertical component of C. Let's just substitute into our equation. Is this, and then what we do? We subtract 285.63 newtons from both sides of the equation, isn't it? Okay, or transpose, and then becomes negative 285.63. And then the vertical component of C. Right, I want to show you the other method. We know that this is the vertical, we've discussed all this, but now we can use the sine of angle 35 and cosine of angle 35. Let me show you how we can do that. So we have our, this is the side here, this side, the horizontal component of force R. So this is the opposite side. If you look at our reference angle 35, this is the opposite side. And then R is the hypotenuse, isn't it? So we can say R sine 35 is equal to 200. Because this is R sine 35. Let me just show you. We're saying we have this angle sine 35. Sine 35 degrees is equal to the horizontal component over R. The vertical component, which is F R X over R. And then we multiply by R both sides, and then we get that F R X is equal to R sine 35. Okay, since the system is at equilibrium, this R sine 35 is equal to what? 200 newtons, which is this. Okay, right. Now, what is R? From this, what is R? We can see that R is equal to, we divide by sine 35 both sides. R is equal to 200 divided by sine 35. So this is like 200 divided by sine 35 degrees. Okay, right. So this is our R. So we can find the vertical component now. Okay, the vertical component is adjacent to the angle 35 degrees there. So we can use cosine of angle 35. So which is cosine cos 35 degrees is equal to the vertical component of R, FRY over our R. Okay, and then we multiply by R on both sides. R times cos 35 degrees is equal to the vertical component of R. Right, and then what is R? R is this, we got this, 200 over sine 35. So where there's R here, we put 200 over sine 35 and then we get something like this. See that? And then we just put this in the calculator. That is the vertical component of R. So now we have vertical component of R, we have our weight, so we can find the vertical component of C. Go back to our equation, substitute what we have, and then we subtract 285,63 from both sides of the equation. What do we get? We get our answer. You see, we're getting the same answer.